Welcome back to my channel Electronic Science Tutorial. This is the 15th class of Operational Amplifier. Today I will discuss the anti-logarithmic amplifier by using an op-amp. In my previous class I discussed the logarithmic amplifier by using op-amp. Today I will discuss the anti-logarithmic amplifier by using an op-amp. So without any time waste, let's start our class. So, what is the anti-logarithmic amplifier circuit by using an op-amp? This is the anti-logarithmic amplifier circuit by using an op-amp. This is the basic circuit. If we compare with the logarithmic amplifier circuit, we can easily saw that here the input parameter is diode and the feedback parameter is resistor. But in the logarithmic amplifier circuit, the input parameter is the resistor and the feedback parameter is connected, that is diode. So this is the basic difference between logarithmic amplifier circuit and anti-logarithmic amplifier circuit. Just if we change the position of the diode and the resistor, then we get logarithmic amplifier and anti-logarithmic amplifier by using op-amp. One supplied voltage V1 is applied at the diode and feedback resistor is connected at the inverting terminal and the output terminal, and non-inverting terminal is connected with the ground connection. So this is the anti-logarithmic amplifier circuit by using an op-amp. Now here we have considered input current as diode current and the feedback current is the resistor current. So first of all we consider the feedback current. That means the feedback current is IF, right? So IF equal to, in this point, this is the virtual ground point, this value is 0. So 0 minus V0, that means the potential difference between these 2 points, that is 0 minus V0 divided by RF. So this is the feedback current, that is IF equal to 0 minus V0 divided by RF. That is equal to V0 equal to minus IF RF. Now, what is the diode current? We know the diode current is ID equal to IS e to the power Vf divided by eta Vt. Now, putting the value of output voltage, we obtained the diode current is putting the value of output voltage, we obtain V0 equal to minus IF. If we put the diode current in this value, in this equation, what we get? That is minus Is Rf e to the power Vf divided by eta Vt, right? So now the KVL equation applied around the input side of the inverting amplifier of the op-amp. KVL equation now we applied at the input side of the op-amp. So here what is the voltage? One is V1 voltage, that is the supplied voltage, and the other one is the diode voltage, that is Vf voltage. So V1 minus Vf equal to 0. If we apply one KVL equation around the input side of the inverting amplifier of the op-amp, we get V1 minus Vf equal to 0. V1 is the input supplied voltage and Vf is the diode forward voltage. So V1 equal to Vf, right? That means we can write, that is V0 equal to minus Is e to the power, in case of Vf we have to write V1. We can easily write V1, right? So V1 divided by eta Vt Rf. So this is the output voltage which is proportional to the anti-logarithmic amplifier of the input supplied voltage. right? So this is the calculation of anti-logarithmic amplifier by using an op-amp. First of all, we have to consider the feedback current. Then we have to consider the diode current. When we get the diode current and the feedback current, the diode from the feedback current we get the output voltage. In this equation, that means V0 equal to minus IFRF, we have to put the diode equation value. Then we have to consider one KVL equation around the input side of the inverting amplifier of the op-amp. We get V1 equal to Vf. Then in this equation, that means in this output voltage equation, we have to replace this Vf value by V1 value. So we get this V0 equal to minus Is e to the power V1 divided by eta Vt Rf. That means anti-logarithmic amplifier is an electronic circuit that produces an output that is proportional to the anti-log of the applied input. Right? Hope you understand this topic. Thank you. If you like, do like, share and subscribe my channel.